Let's simplify this expression. For number 1, we have x to the 4 to the power of 5. So multiply these two, right? 4 times 5, that's 20. So we have x to the 20 times y cubed to the power of 4. Multiply these two, y to the 12 times y squared. So these two terms have the same base, so we can add exponents. X to the 20 times y to the 12 plus 2, right? So that is equal to x to the power of 20, y to the power of 14. Number 2 is equal to a to the 4 times b squared to the power of 5. So multiply these two. b to the 2 times 5, 10. Times a squared to the power of 3. Multiply them. a to the 6 times b to the 3 to the power of 2. b to the 6. Right? So here, these two terms have a base a. So that's going to be a to the 4 plus 6. b to the 10, b to the 6. So times b to the 10 plus 6, right? So that is equal to a to the 4 plus 6, 10. b to the 10 plus 6, 16. Number 3. If negative is multiplied an even number of times, then that's positive, right? So that is equal to positive 3 squared times x cubed to the power of 5. Multiply these two. X to the 15 times we have x squared. So these two terms have same base x. 3 squared is 9. And x to the 15 plus 2. So that is equal to 9x to the 17. Number 4 is equal to, we have a negative and it is multiplied an odd number of times. That's negative, right? We have 2 cubed times a to the 6 times a to the 3 times 4, 12. So negative 2 cubed is 8. We have a to the 6, a to the 12. So add exponent. So that's going to be negative 8, a to the 18. Number 5, we have a 4 squared, which is equal to 16 times x squared to the power of 4, x to the 2 times 4, 8, times x to the 6, times y to the 4 squared, multiply them, y to the 8 times y cubed. So we have 16 times x to the, here we have x to the 8, x to the 6. Add exponents. A plus 6 times y to the 8 plus 3, right? So that is equal to 16 x to the 14 y to the 11. Number 6, we have this expression and it says x and y are positive integers. Okay, let's simplify this. We have a to the 4 to the power of x, so multiply these two. So that is equal to a to the 4x times 2 times 3y, that's b to the 6y, times 2x times 3, that's 6x, a to the 6x, times b to the 4 times 2, that's 8. So we have two terms with the base a, two terms with the base b. So that is equal to there are multiplications, right? So a to the 4x plus 6x times b to the 6y plus 8. 4x plus 6x, we can add them, right? That's 10x. And b, 6y plus 8, we just have to leave 6y plus 8. Review exercise number 2. We're going to simplify this expression. Number 1, we have a squared to the power of 3. So that is equal to a to the 2 times 3, 6, divided by a to the 4, right? So it's a division. We're going to have to subtract exponent, 6 minus 4. So that's a square. Number 2, we have x to the 4 to the power of 5. So 4 times 5 gives us x to the 20, divided by x to the 4, divided by x to the 5 times 2, that's 10. So if it's a division, we have to subtract exponents, right? So x to the 20 minus 4. Another division, divided by x to the 10, so minus 10. So that's going to be 20 minus 4, that's 16. 16 minus 10, that's 6. So it is x to the power of 6. Number 3, we have 2 to the power of 10 divided by 2 to the power of 5 divided by 2 squared to the power of 4. That's 2 times 4, 2 to the power of 8, right? So they are divisions. So what we have to do is we have to subtract 5 and 8 from 10. So 10 minus 5 minus 8. So that is equal to, we have negative exponent. 10 minus 5, that's 5. 5 minus 8, that's negative 3. Right? So if we have a negative in our exponent, what we have to do is we have to write 2 to the power of 3 in our denominator, right? Just eliminate this negative exponent right here and write 2 to the 3 in our denominator. Okay? So that is equal to 2 cubed is 8, right? So the final answer is 1 over 8. Number 4, we have a to the power of 25 divided by a to the 4 to the power of 2. That's a to the 8 divided by 3 times 5, a to the 15. So that is equal to a to the 25 division minus 8, another division minus 15. So 25 minus 8, that's 17. 17 minus 15, that's 2, right? So this expression is equal to a square. Number 5, we have 6 times 5x to the power of 30 divided by 4 times 4, that's x to the power of 16, divided by 2 times 6, that's x to the power of 12. So x to the division, same base, 30 minus 16, another division, same base, minus 12, right? So 30 minus 16, that's 14. 14 minus 12, that's 2. So we have x squared. Number 6, we have this expression right here, and it says x is a positive integer. So let's simplify this. Number 6 is equal to, we have a to the power of 5x divided by a to the power of x divided by, here, 3x times 2, that's 6x, right? So a to the power of 6x. So we have three terms and they're all base a. So a to the 5x division minus x, another division minus 6x. So 5x minus x minus 6x, that is equal to 5x minus x, that's 4x, and we have a minus 6x. 4 minus 6, that's negative 2x. So we have a to the power of negative 2x. And if we have negative in our exponents, then eliminate negative and write that in denominator, right? So a to the power of 2x. Review exercise number 3. We're going to simplify these expressions. For number 1, we have x squared times y, all of this expression to the power of 5. So what we have to do is we have to apply the distributive property, right? So 5 times 2 and 5 times 1. So x to the 2 times 5 or 5 times 2, that's 10. And y 1 times 5 or 5 times 1, that's 5. Number 2, if negative is multiplied an even number of times, that's positive, right? So this is just a positive. 2 squared, 2 times 1, 2 squared. 6 times 2, that's x to the 12. And y 3 times 2, y to the 6, right? 2 squared is 4, so we can write 4x to the 12, y to the 6. Number 3, so we have 3x to the 4, y to the 5, z squared. All of this expression to the power of 3. So we're going to distribute 3 to the power of 1 here, 3 to the power of 4, 3, 5, 3, 2. So 3 to the 1 times 3, that's a 3. X to the 4 times 3, that's a 12. Y to the 5 times 3, that's a 15. And z 2 times 3, 6, right? So that's going to be 3 cubed, which is a 27. 27x to the 12, y 15, z to the 6. Okay, number 4, we have 2, 1 times 4, so 2 to the 4, right? So 2 to the power of 4, a 1 times 4, right? That's a to the power of 4. B 3 times 4, that's b to the 12. So 2 to the 4, 2 times 2 times 2 times 2, that's 2 to the 4, right? 4 times 4, that is equal to 16. So this is a 16a to the 4 over b to the 12. Number 5, if negative is multiplied by an odd number of times, then that's negative. So we have negative 3 cubed, right? 3 cubed. A to the 3 times 3, a to the 9. And 3 times 1, that's 3. So c to the power of 3. And 3 times 5, that's b to the power of 15. So that is equal to negative 3 times 3 times 3, that's 9 times 3, which is 27. So we have 27, a to the 9, c 3, b to the power of 15. Number 6, we have this expression and it says x is positive integer. So number 6 is equal to 3 times 4x. So that's c to the power of 3 times 4, 12x. And we have 1 times 4x, 4 times 4x. So 1 times 4x, that's a to the 4x, and b to the 4 times 4x, that's a 16x. Find the value of a and b in the following equation. For number 1, we have this expression on the left-hand side and x to the 17, y to the 20 on the right-hand side. So what I'm going to do is I'm going to simplify all of this expression right here and compare to the expression on the right-hand side. So let's do that. So we have x to the 5 times, here y to the 2b to the power of a 5. So 2b times 5, that's y to the 10b, times a times the 3, that's x to the 3a. And this is equal to x to the 17, y to the 20. On the left hand side, we have two terms with the base x. So let's simplify this. So that's going to be x to the, it's multiplication, right? So we have to add exponents. X to the power of 5 plus 3a, and we have y to the power of 10b, and that is equal to x to the 17, y to the 20, right? So here we have the term with the base x, here term with the base x. They're equal to each other, right? They are equal to each other, which means 5 plus 3a must be equal to 17. So we have 5, we have 5 plus 3a is equal to 17, and 3a equal to subtract 5, that's a 12, divided by 3 gives us a is equal to 4, right? Here also we have y to the power of 10b, y to the power of 20. 10b has to be equal to 20, right? So we have 10b is equal to 20. So b is equal to 2. Number 2. Just like number 1, let's simplify the expression on the left-hand side. So 1 times 3, that's 3, right? So we have 2, 3, and 2a times 3, that's x to the 2a times 3, 6a, right? Here, denominator, we have y to the power of 3b plus 1. So 3b plus 1 times 3, that's y to the 3 times 3b plus 1. And this one is equal to 8x to the power of 12 over y to the power of 12. So let's rewrite this expression right over here. We have 2 cubed, which is equal to 8, and x to the power of 6a. And if we look at this denominator right here, that's 3 times 3b, 3 times 1, right? So that's going to be y to the power of 3 times 3b, that's 9b. 3 times 1, that's plus 3. And this is equal to, again, 8x to the 12 over y to the 12, right? So let's compare each term right here. We have 8 here. We have x to the 6a. This is x to the 12. So 6a must be equal to 12. So 6a must be equal to 12. So a is equal to 2. Now we have 9b plus 3 is equal to 12, right? So 9b plus 3 is equal to 12. So 9b subtract 3 each side, that's 9. So b is equal to 1. So a is equal to 2 and b is equal to 1. Number 3, let's simplify the expression on the left-hand side. So we have 5 times 2a. 5 times 2a is 10a times 3 times 2b, that's y to the 6b, times y to the 2b is equal to x to the 10, y to the 24. So we have two terms with the base y. So x to the 10a times y to the 6b, this one plus this one, right? 6b plus 2b, that's 8b, right? So y to the 8b is equal to x to the 10, y to the 24. So all of this expression is equal to this, which means this must be equal to this. So 10a is equal to 10, right? So we have 10a is equal to 10, a is equal to 1. And also 8b must be equal to 24. So 8b must be equal to 24. So b is equal to what? B is a 3. So a is equal to 1, b is a 3. Number 4, negative is multiplied 3 times, right? So that's negative. So negative 3, 1 times 3, that's 3 cubed, right? 3 cubed. B plus 1 times 3, y 3 times b plus 1. And 2a minus 1 times 3, that's going to be x 3 times 2a minus 1. And all of this expression is equal to negative 27 y to the power of 12 over x to the 9. X to the power of 9. Right? So let's simplify the left-hand side a little bit more. We have negative here. We have a 3 cubed. 3 cubed is 27, right? So 27 y to the 3 times b, 3b, 3 times 1 plus 3 over x to the 3 times 2a, 6a, 3 times 1 minus 3. And that is equal to negative 27y to the 12 over x to the 9. So we have a negative 27 here, negative 27 here. Y to the 3b plus 3, 3b plus 3, right? Y to the 12. So this 3b plus 3 has to be equal to 12. So 3b plus 3 is equal to 12. So 3b is equal to 9, b is equal to 3, right? Here we have x to the power of 6a minus 3, x to the power of 9. So 6a minus 3 has to be equal to 9. So we have a 6a minus 3 is equal to 9. So 6a is equal to 12 plus 3 divided by 6 gives us a is equal to 2. So a is equal to 2 and b is equal to 3. Find x in the following equation. For number 1, we have 2 to the power of x times 16 is equal to 4 to the x, right? So this equation has the variable in an exponent, in our exponents, right? So to solve this type of equation, each term must have the same base. That's the key. Okay, so let's try number 1. We have 2 to the x, base is 2. We have a 16 here, right? 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2, right? So 16 is 2 times 2 times 2 times 2. 2 to the 4, right? And we have a 4 here. 4 is just a 2 times 2, which is equal to 2 squared, right? So we're going to rewrite this equation, number 1 equation, down here. We have 2tx times 2 to the power of 4 is equal to 4 is 2 squared, and we have the power, the exponent x, right? So 2 to the x times 2 to the 4 is 2 to the x plus 4, right? Is equal to this times this, that's 2 to the 2x. So we have same base 2, right? And all of this expression right here is equal to this, which means this expression x plus 4 must be equal to this expression 2x. So x plus 4 is equal to 2x. Subtract x each side, so x is equal to 4. Okay, number 2. We have a 27 here. 27, 9, 9, right? So let's write the factor tree for 27. 27 is 3 times 9, and 9 is 3 times 3, right? So 27 is 3 times 3 times 3, 3 cubed, right? This is 3 cubed. And 9 is just 3 times 3. So that's 3 squared. So we can actually change all of this term right here in terms of base 3, right? We can convert this in base 3. So that's 3 cubed, and we have exponent 4 divided by 3 squared, and we have x is equal to 9 3 squared. So 3 times 4, that's 12, divided by x times 2, or 2 times x, 3 to the 2x is equal to 3 squared. Here on the left hand side we have division, so same base, 3 to the 12 minus 2x is equal to 3 squared. So all of this expression is equal to this same base 3, right? So we must have 12 minus 2x is equal to 2, right? So 12 minus 2x is equal to 2. So negative 2x is equal to, subtract 12 each side, negative 10. So divided by negative 2, x is equal to 5. Number 3, we have 9, 3, base 27. So again, 9 is 3 times 3, 3 squared. 27 from the previous question, 27 is 3 cubed, right? 3 times 3 times 3, so that's 3 cubed. So 9, 3 squared, and we have power x times 3 to the x times 4, that's 4x, is equal to 27, 3 cubed, and we have x minus 1. So 2 times x, 3 to the 2x, times 3 to the 4x is equal to, 3 times x, that's 3x, 3 times negative 1 minus 3, right? So let's simplify the expression on the left hand side. We have 3 to the 2x times 3 to the 4x. The bases are 3, so 3 to the 2x plus 4x is equal to 3 to the 3x minus 3. So this is a 6x, right? This is a 3x minus 3. So let me just write 2x plus 4x is equal to 3x minus 3. So 6x is equal to 3x minus 3. So we have 6x is equal to 3x minus 3. So subtract 3x each side. So x is what? -1. Number 4, we have 32, 4, 8, and 1/2 here, right? So 32 is 2 times 16, and 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So how many 2's are multiplied? 1, 2, 3, 4, 5. So 2 to the power of 5 is equal to 32, right? So 32 is 2 to the power of 5. 4 is just 2 times 2, 2 squared. 8 is equal to 2 times 2 times 2, which is equal to 2 cubed. And 1 over 2. 1 over 2 is actually what? We can write this one as 2 to the power of -1, right? Because 1 over 2 is 1 over 2 to the power of 1. Is that right? Okay, so let's rewrite this equation. 32, we have 2 to the 5 divided by 2 squared, and we have x plus 1 divided by 8, 2 cubed, is equal to 2 to the power of -1, right? So they're all now in terms of base 2, right? So we're going to simplify the left-hand side, the expression on the left-hand side. So 2 to the 5 divided by 2 to the 2 times x, 2x, 2 times 1 plus 2 divided by 2 cubed is equal to 2 to the -1, right? So division, we have to subtract, right? Subtract exponents. 5 minus 2x plus 2 minus 3 is equal to 2 to the -1. So all of this expression must be equal to -1 because they all have a base 2, right? So let's write 5 minus 2x plus 2 minus 3 is equal to -1. 5 minus 2x minus 2 minus 3 is equal to -1. So we have 5 minus 2, 3. 3 minus 3, that's 0. So -2x is equal to -1. So divided by -2 each side, x is equal to 1/2. If k is equal to 2 to the power of 3, find each of the following in terms of k. So for number 1, we have 64. First thing we have to do is we have to convert this number with the base 2, right? So 64 is 2 times 32. 32 is 2 times 16. 2 times 8. 2 times 4. 2 times 2. So how many 2's? 1, 2, 3, 4, 5, 6. So 64 is 2 to the 6. That's 2 to the 6. And we have to write this number in terms of k, right? K is 2 cubed. So we must have 2 cubed from 2 to the power of 6. So we can actually write 6 is 3 times 2, right? So that's going to be 2 cubed to the power of 2. Because this times this is equal to 2 times 3. So we can write 2 cubed is k squared, right? For number 2, we have a 2 to the power of 12. So that is equal to, the base is 2 already. So 2, well, 12 is 3 times 4, right? So 2 cubed to the power of 4. And 2 cubed, this one is k. So that's going to be k to the power of 4. Number 3, we have 4, base 4 to the power of 9. 4 is 2 times 2, 2 squared, right? So that is equal to 2 squared to the power of 9. So that's 2 to the 2 times 9, 18. And we must have a 2 cube, right? Because that's k. So that is equal to 2 to the 18 is 3 times 6, right? So that's 2 cube to the power of 6. And this one is k. So this is equal to k to the power of 6. Right? Number 4, we have 8. 8 is equal to 2 times 2 times 2, 2 cube, right? So that's 2 cube to the power of 5. We have 2 cube already here, which is k. So that's just k to the power of 5. Using law of exponents, simplify each of the following. For number 1, we have a 5 squared plus 5 squared plus 5 squared plus 5 squared plus 5 squared, right? So let's say we are adding a plus a plus a. That is equal to 3a, right? What if we have a square plus a square plus a square? We are adding all 3a squares. So that's going to be 3a squares. But what if we have a plus b? We cannot add it, right? If we have a plus a square, we cannot add them, right? So we can add variables when they are exactly same variables, right? If they are like terms, or we call it similar terms sometimes. If they are like terms, we can add them. If they are not like terms, we cannot add them. For number 1, we have a 5 square. They're all 5 square. How many of them? 5 of them, right? So that's going to be 5 square, 5 of them, right? So that's going to be, well, just 5 is 5 to the power of 1, right? So that's going to be 5 to the 1 plus 2. 1 plus 2 is equal to 5 to the power of 3. Does it make sense? Okay, let's try number 2. We have 7 to the 4 plus, they're all 7 to the power of 4. How many? 1, 2, 3, 4, 5, 6, 7, right? So that is equal to 7 to the 4, how many? 7 of them. Same base. Exponent 1, 4. So what we can do is we can add these two numbers. So that's going to be 7 to the power of 5. Review exercise number 8. If m is equal to 3 to the power of n plus 1, the question is to find 9 to the power of n plus 2 in terms of m, right? So we have m is equal to 3 to the n plus 1. Let's simplify this first. M is equal to, well, 3 to the power of n plus 1 is equal to 3 to the n times 3 to the power of 1, right? You know, same base. If these two terms are multiplied, we add these two exponents, just like this, right? So we can say that 3 to the n is equal to m over 3, right? Here we have base 9. So I'm going to change this base 9 to base 3. 9 is equal to 3 times 3, 3 squared, right? So that is equal to 3 squared, and all of expression to the power of n plus 2. And we have to write this expression in terms of m. So I'm going to distribute it. 3 to the 2n plus 4, right? Plus 4, right? So that is equal to 3 to the 2n times the same base 3 to the 4, right? Same base multiply together, then we add these two, right? So 3 to the n here. 3 to the n is m over 3. So we must have a 3 to the n. We have a 3 to the 2n here. So I'm going to write 3 to the n square, right? 2 times n is 2n, right? And we have a 3 to the 4. 3 to the 4 is, you can just write 3 to the 4, or if you multiply 3 by 3 by 3 by 3, that's 9 times 9, that's 81, right? So that's 81 actually. So we're almost done. 3 to the n, that's m over 3. So m over 3, all of this expression squared times 81. So that is equal to m squared, right? And 3 squared. So m squared over 3 squared times 81. 3 squared is 9. So 9 times 1, 9 times 9. So we have 9m squared. If a is equal to 2 to the power of b minus 1, the question is to find 4 to the power of 2b in terms of a. So just like review exercise 08, we're going to simplify this first, and we're going to write this in terms of a. So we have a is equal to 2 to the power of b minus 1. That's a 2 to the power of a b divided by 2 to the power of 1, right? So multiply by 2 each side. 2a is equal to 2 to the b, right? Here 4 is 2 squared. So we can write this expression 4 to the 2b is equal to 2 squared to the power of 2b, right? So that is equal to 2 times 2b, that's 2 to the 4b, right? 2 to the b is 2a, and we have to write this expression in terms of a, right? So we're going to rewrite this expression 2 to the b to the power over 4, because 4 times b is equal to 4b, right? So 2 to the power of b, that's 2a. So 2a to the power of 4. So 2 to the power of 4, a to the power of 4. That is equal to 2 to the power of 4, 2 times 2 times 2 times 2. That's 4 times 4, 16. So 16a to the power of 4. The question is to solve the equation 2 to the power of x plus 2 plus 2 to the power of x is equal to 40. Well, we're going to simplify the expression on the left-hand side, but what we have to be careful is that this is not multiplication. This is addition, right? So if we rewrite this expression right here, that's 2 to the x times 2 squared, right? If it's multiplication, we add these two, and that's x plus 2 right there. Plus we have 2 to the x is equal to 40. So this one is a 4, right? So let me rewrite this expression right here. 4 times 2 to the x plus 2 to the x is equal to 40. Here we have same term right here, 2 to the x, 2 to the x. 4 of them, 1 of them. If we add these two, that's going to be 5 times 2 to the x, right? Just like if we have 4a plus a, that's going to be 5a, right? Like 4a squared plus a squared, that's, a squared, we have 4 of them. A squared, 1 of them, like 1, right? So 4 plus 1, that's a squared, 5 of them. Does that make sense? 2 to the x, we have 4 of them. 2 to the x, 1 of them. Add it, that's going to be 5, 2 to the x, right? So divided by 5 gives us 2 to the x. 2 to the power of x is equal to 8, right? Now, we know that 8 is equal to 2 to the power of 3. So 2 to the x is equal to 2 to the power of 3. Now, same base. Then x is equal to what? X is equal to 3. If m is equal to 2 to the power of a plus 2 and n is equal to 3 to the power of 1 minus a, the question is to find 72 to the power of a in terms of m and n. So let's simplify these two expressions right here. So we have m is equal to 2 to the power of a plus 2. So that is equal to 2 to the a times 2 squared. And this is 4, right? So m is equal to 4 times 2 to the a, which means 2 to the power of a is equal to m over 4, right? And we also have n is equal to 3 to the 1 minus a. So n is equal to 3 to the power of 1. Let me erase this. 3 to the power of 1 over 3 to the power of a, right? If it's a division, we subtract exponents. So 3 to the a is equal to 3 over n, right? I multiplied by, 3 to the a each side and divided by n, okay? So 3 to the power of a is equal to 3 over n. Does that make sense? Okay, 72 to the power of a. 72 is 2 times 36. That's 3 times 12. That's 3 times 4. And 4 is 2 times 2, right? So 72 is 2. How many 2's? 3 2's are multiplied. So 2 cubed times how many 3's? 2 3's, right? So 3 squared. So 72 is 2 cubed times 3 squared. So let me erase this. And let's simplify 72 to the power of a. That's 72 is 2 cubed 3 squared, and we have a power a, and we're going to distribute it. 3 times a, that's 2 to the 3a times 3 to the power of 2a. And we know that 2 to the power of a is equal to this, and 3 to the power of a is 3 over n. And we have to write this in terms of m and n, right? So we're going to rewrite this expression 2 to the a, all of this thing to the power of 3 times 3 to the a, all of this expression to the power of 2. Then we can write here 2 to the a, m over 4. So m over 4 to the power of 3, 3 to the power of a, that's 3 over n. So 3 over n to the power of 2. So we're almost done. Here, m cubed over 4 cubed times 3 square over n square, right? So that is equal to, well, 3 squared, that's 9. So 9m squared, numerator. 4 cube, 4 times 4 times 4. That's a 16 times 4. So that's a 64. So 64 n squared.